atom is now situated with the nucleus and the electron orbits around it. But let's take a look and see now about what particular particles are going to be in an atom, are going to constitute that atom. Okay? So now let's take a look at fundamental particles. Okay, so fundamental particles. Let's see. So the atomic nucleus has been kind of explored, I guess, by using particle accelerators. Okay. Particle accelerators are huge machines, and it's kind of maybe a little ironic that the smaller the scale you need to look at, the bigger the machine you kind of need to do that. So these particle accelerators are vast, miles and miles in diameter, and just expand over lots and lots of space. But what they do is accelerate particles up to speeds almost to the speed of light, and then they crash into a target and blast the thing to smithereens. And by seeing what comes out of it, then you can kind of investigate what the constituent particles are of not only nuclei, but also the neutrons and protons and other constituent particles like that. Okay, according to the book, he says there's about 100 subatomic particles. Okay, so that would be 100 particles that are on smaller than the scale of protons. Okay, so we'll take his word for it. We'll take his word for that. Okay, now it's important that the properties, the chemical properties of an atom, are described by the electron configuration. Okay, so all of the chemical properties of an atom are going to be determined by what the electron configuration of that atom is. Okay, chemical properties and how they interact. A moment ago, we described about how that group 8 on the periodic table, they're very stable, non-reactive. The reason being is they have a complete electron shell in their outer orbit. We'll get to a little bit of that in a minute. But in other words, the electron doesn't want to give up any electrons, and it doesn't want to receive any, because it's a nice, stable state for an atom to be in when it has a full electron shell. Okay? Now, there's multiple levels of shells, so the further down you get in the periodic table, the further and further out you get with the electron shell. But as long as the outermost one is full, then that atom really doesn't want to react very readily. Okay? But the chemical properties of an atom are determined by the electron configuration. Okay, not the nucleus. All right, nucleus is way separated from that. So if you can kind of conceptualize it, most of an atom is empty space. Okay, so suppose we stood here and we had a representation of an atomic nucleus. So, and say that representation of our atomic nucleus was a basketball. Okay, so suppose we were here with our basketball and that represented the nucleus. Where do you think the first orbit of electrons would be?
Football field away.
That's sort of close. I mean, you're on the right track. It's like about a mile, literally. It's really, really far away, right? So it's not like the electrons or the protons and neutrons are here in orbit, and electrons are like really compact. It's a vast amount of space there. Okay. So the chemical properties deal with the electron configuration, not the nucleus. Okay, so we'll keep that in mind. Okay, now that will be the chemical properties. When it comes to our X-ray interactions, it's all about the nucleus. Okay, so we'll talk about that later. Okay, let's we'll introduce some units. Atomic mass. Atomic mass is 1 AMU, 1 atomic mass unit is the, not really shorthand, but an atomic mass unit is defined as the mass of 1/12, defined as a mass of 1 proton. It's actually defined as 1/12 of the mass of carbon 12, but same thing.